for movement, they are not free to move. They're very closely packed with each other. They are tightly packed, and the space between the particles is very less, right? And what about the force of attraction between the particles here in case of solids? Whether it is
They are
highest or
very
whether
strong.
it is very strong, right?
The
Force of
very
attraction is very strong, whereas the space between the particles is very less. Let us compare it with the liquids. So if I take this as a liquid sample, we know that the particles are near to each other, but comparatively they are little bit free to move, right? Now, when I'm talking about gases, if I take this as a gas sample, gaseous sample, we know that the particles are very free to move, and the space between the particles is too large when compared to that of solid and liquid. So I'll just write yes for solid, liquid, and gas. Now, let us talk about, mainly I'll be talking about two modes of heat transfer. There are three modes, but for now I'll be just explaining two modes. Okay, one is conduction, and the other one I'll be explaining about convection. Okay, so before starting, I want to just ask one simple question. Now we have seen in the kitchen when something is cooked, when the food is cooked, right? Why do you think the vessels are made of metals, and why do you think the handle is made up of plastic? Usually it will be plastic or some other material. We
Yeah,
do not.
because
Yeah.
metals are a good conductor of heat, whereas plastic is not.
Yes, very good. Yes. So when we are talking about metals, these are good conductors of heat. So now the term conductors, right? So that is related to conduction here. So because we are talking about solids, metals are solids, right? Now these metals, they are good conductors of heat.
Hello.
Why do they conduct heat? Because of the process
Hello.
of conduction.
Ma'am?
Yeah.
Yeah, ma'am, please close this mini screen. No, it's obstructing the view of the board. Yeah.
Oh,
We have to close it. Close it.
This one. Okay. Yeah. So I hope it is clear. Now, since we are talking about this conduction, this is nothing but because of the process of conduction, there is the transfer of heat. Okay. Now let us talk about what is conduction in specific. So this conduction is mainly seen only in the solids, or in other words, I can say in solids, this process of conduction is very prominent when compared to that of the liquids or the gases. So let us take one solid sample. This is one solid sample. Okay. Now I'm going to heat this solid sample. Okay, just imagine I'm going to heat one metal strip. I'm going to take, I'm going to heat it on one side with the candle. Okay, now what is going to happen when I start heating from this side, from this one end? These molecules, whatever are there in the solids, we know that the molecules are very close to each other in case of solids, right? Now, whenever you're heating, this molecule starts vibrating fast. So because of the vibration, the energy is transferred to the next molecule. Now, this energy from this molecule will be transferred to the another molecule, and it goes on. So what happens? Even though you're heating from this end, the heat is occurring from this end. Because of the vibration of the particles, the heat will start flowing from here to the other end. Right? This is how the conduction takes place in the solids. Now, my question is, why do you think conduction is very prominent only in solids? Why not in liquids and gases? Why do you think?
Ma'am, can you repeat the question again?
Yeah, so now I just explained, right, how the conduction occurs. Because the vibration of the particles take place and the heat is transferred from one molecule to the next molecule. Now, my question is, why conduction is more prominent in solids only? Why not in liquids or gases? Any idea?
Because in liquid, the particles are not vibrating with each other. The space is little far apart. And
yes,
in
very good.
gases, so they are more far apart.
Yes, very good. That's the exact answer. Yes, in case of liquids, we know that the particles are not very close to each other. So the transfer of this energy will be a little bit difficult when compared to that of the transfer of energy that we see in the case of the solids. So because of this, in case of solids, the conduction is a very prominent mode of heat transfer. Now, let us talk about convection. So convection is mainly seen in this liquids and gases. Okay, so conduction we already know it is prominent in solids. Now in case of liquids and gases, it is convection which is highly prominent. Now let us talk about convection. Let me just give a simple introduction, then I'll ask you one question. So we know that density, do you know the formula for density? How do we calculate density?
Density equals mass by volume.
Yes, very good. Mass by volume, right? So now you just imagine, now we are talking only about liquids and gases because convection is seen in these both, okay, mainly in liquids and gases. Now, just imagine you're going to heat a liquid. Now what happens? The temperature increases, right? Temperature increases when you're heating a liquid. When the temperature increases, obviously we know that expansion happens, right? The liquid undergoes expansion, the volume increases. Now, when expansion occurs, expansion also becomes more. So expansion means I'm talking about volume, right? So if the expansion becomes more, we know that the volume is increasing. Now, just look at this particular formula. volume is increasing. Do you think there will be any change in the mass if the volume is just increasing? Will the mass also change?
No.
No, right? Because overall, how much of matter is present in a liquid or gas, that is fixed. That is not going to change. Only the volume increases because of the expansion, right? So mass is fixed. So this is fixed. There is no change, but only this volume is increasing. If the volume increases, what happens to the density? Now we know that according to this particular equation, density and volume, how they are related to each other. Okay, no problem. So density and volume, you can see here. See, density and volume. If I compare these two, as density increases, volume decreases, because you see they are inversely proportional to each other. Right? Now, if density decreases, volume increases. Please keep this in mind. Right? Now, in this situation, we know that volume is increasing. Correct? So if volume is increasing, what happens to the density?
Decreases.
Decreases. Correct. Very good. So now, so let us consider one beaker. Okay. And here there is water, and you're going to heat this sample of water, okay, with the burner or whatever it is. Okay, so I'm just drawing a rough diagram just for you to understand. Okay, now you're heating it from here. So when you're starting to heat from the bottom of the beaker, now here there will be molecules, right? Now what happens? These liquid molecules, they start heating up. Now as they start heating up, what happens? They start to expand. So expansion means volume increases, right? If volume increases, density decreases. Just we discussed about it, right?
Yeah.
So if density decreases, what do you think will happen? Whether it will move upwards or whether it will sink to the bottom?
The density.
If the density is less, whether it will float or whether it will sink?
It will float.
Yes, it will float. Very good. So here, since the density is decreasing, these molecules, they prefer to float. They prefer to go up. Now, all these molecules which are heated up, this sample of liquid which is heated up goes above, right? Now, whatever sample was above, it starts coming downwards, because in the upper region, in this region, there is no expansion that is taking place, because we are not giving heat from this side, right? So whatever is here, now this sample of liquid starts coming downwards. Right. So because of this movement of the molecules of the liquid, so whatever is heated, it goes up. Whatever is cool, which is in the upper surface, it comes down. So there is literally movement of liquid molecules throughout the sample. So this particular movement is called as convection. So heat transfer in case of liquids, or in the case of gases, even in the gases, it's the same reason. Okay, as the gases expand, their density decreases, they move upwards. Whatever was cooler will come downwards. So that is how the movement of the particles takes place and the heat transfer occurs. So this is called as convection, right? Now, one simple daily life example. I'll just finish with physics with this particular question. Yes. Why do you think air conditioners have to be kept on the top? Okay, if you're considering one room, why do you think air conditioners have to be kept above? Why not place it near the ground? Can you just tell me based on this convection? Any idea? Now what happens? Air conditioner, why do we require them? See, we are, now suppose you are considering one room, right? We are sitting, let us say we are sitting on the chair and air conditioner is above. Now, whatever the cool air is there, now just I explained, right? Whatever is cool, it comes down, right? Whatever is hot, it goes upwards. Whatever is cool, it is coming downwards because of convection. Now, if the air conditioner is up, what happens? Whatever the cool air is there, it comes downwards because its density is higher, so that we can feel cooler because of the air conditioner. Are you able to understand?
Yes.
Okay. Do you want me to go slower or fast? How do you think for the next?
Little slower would be nice.
Little slower. Okay, fine. So whether you're okay with this convention and convection as well as conduction, is it clear, these two topics?
Yes, ma'am.
Okay. So shall we move to chemistry?
Yes.
Yes. Okay. So I'll start with another topic for chemistry. So we'll be talking about structure of atom. Okay, I'll be explaining just an introduction part for writing the electronic configuration. That is how we are going to write the electronic structure for any atom. So that is what I'm going to explain in this particular topic. So I hope you know the elements from atomic number 1 to 20.
Yes, ma'am.
Yeah. Okay. So we shall start with the simplest one. Let me start with carbon. Okay. Can you tell me the atomic number of carbon? Okay, no problem. I'll just write all the... Yeah, 6. Very good. So hydrogen, helium, beryllium, boron, nitrogen, oxygen, fluorine, and neon. These are the first 10 elements according to the atomic number. Okay, so we know that carbon is here. So 1, 2, 3, 4, 5, 6. So we are talking about carbon with the atomic number 6. Now, from the atomic number 6, we get to know a certain other information. So let me tell from the atomic number what are the different things you can infer. Okay, so first thing is that atomic number is equal to the number of electrons. Okay, and this is also equal to the number of protons in the atom. So this is one thing you need to remember. As you already know, you might have already studied. So in an atom, there will be a nucleus and there will be electrons which are around the nucleus in the different shells. Now in the nucleus, you have neutrons plus protons, and the electrons will be around the nucleus in the shells. So these are electrons. Now can you tell me what is the charge on proton?
Positive.
Positive, yes. Charge on electron?
Negative.
Negative, very good. Neutron?
No charge.
Neutral, yes, very good. So we know that here, when I'm talking about atomic number, it is equal to the number of electrons, which is equal to the number of protons. Now, why these both should be equal? The reason is, here, these are negatively charged, right? These are positively charged. Now, if these both are equal, overall, the atom will be neutral. Okay, so now when I'm talking about carbon atom, it should have 6 protons, 6 electrons. Now, from this, now carbon is atomic number 6. From this, whatever I know, number of electrons is 6, number of proton is 6. Now, number of neutrons, how do we calculate? So, we should know something called as the mass number. Now, mass number is equal to number of protons plus number of neutrons. This is one thing you need to remember. Now, we know that number of protons is 6. The carbon has mass number 12. So, from this, what do we understand? How do we calculate the number of neutrons from this? Can you tell me now? The mass number of carbon is 12.
Mom. Excuse me, ma'am.
Please wait. She will be joining. She got a power cut.
Okay.
Yeah, I'm so sorry. There was some glitch from my end. I'll
No problem.
continue. Yeah, I hope it is visible, my screen.
Yes, ma'am.
Yeah, okay. So we were talking about carbon, right? 1 minute. Yeah, so carbon, I told you, atomic number is 6, mass number is 12. So from this, can you calculate the number of neutrons?
Yes, you subtract 12 minus 6, which is 6.
Yes, neutrons is 12 minus 6, that is equal to 6. Yes, very good. So now, we have to remember one more thing. Whenever we are writing the electrons around the nucleus, we have to follow one simple rule. You have to remember this particular formula, 2n square. Okay, so there are various shells around the nucleus, so that how the electrons are arranged in this particular shells. Now, when you're talking about the nucleus, here there will be one shell, another shell. So there will be many shells around the nucleus. Now, to calculate how many electrons are there in the first shell, let us substitute n is equal to 1. So 2 into 1 square is 2, right? So in the first shell in carbon, I can only fill 2 electrons, right? Can you tell me in second shell, how many electrons maximum I can fill? 2 into?
8.
2 into 2 square. Yes, 2 into 4, that is 8. Now, how many electrons are remaining in carbon? Already I have filled 2. So how many are remaining?
You have 4.
4. Yes, very good.